Hi students. There is some confusion about how to draw Lewis structures for ionic compounds still. So what I'm going to do is in this video we'll go through the sheet that I gave you called Lewis dot diagrams for ionic compounds. I'll speak you through it and that should help you. After that I'll draw a couple of examples of Lewis dot diagrams for ionic compounds. So you follow these steps to draw the Lewis dot diagrams for ionic compounds. For example, magnesium chloride. So magnesium chloride is the substance that we're going to draw. The first step is to write out the ionic formula. So we know that magnesium chloride is ionic because it contains a metal, magnesium, and a non-metal chloride. So if you remember your charges on your different ions here, you will know that the ionic formula will be MgCl2. That's because magnesium has a +2 charge and chlorine has a -1 charge, so you need 2 chlorines to balance out the charge of the magnesium. This next step is to draw atoms of these ions using Lewis dots. Remember that only the valence electrons are shown, so even though magnesium has more than this number of electrons, the valence electrons are only 2, so we only draw 2 dots. You can see here that the chlorine will also only have 7 dots, so you draw those in. That's what I've done just here. Now this next step is optional, but it might help you figure out how to draw the final structure. So the step 3 is to draw arrows to show where the electrons are going when an ion is formed. So what I've done is I know that the magnesium is a metal and they lose electrons to form ions. So I'm drawing its electrons going into those empty spaces in the chlorine. So that once this is done, the magnesium will have no electrons and the chlorines will both have 8. The last step is to draw the resultant ions. These should have charges and brackets around the nonmetals to show that they own the valence electrons here. Make sure that they're arranged so that the positive and negative charges are next to each other. For example, in magnesium chloride, magnesium has a +2 charge and is between the -1 charge of the chloride ions. So you can see here the magnesium does have a +2 charge. It doesn't have brackets around it because it has no valence electrons to own. So Mg2+ is fine for magnesium ion. It's then surrounded on either side by the chloride ions. The chloride ions have 8 electrons because they've taken 1 of the magnesium each. We then, because they have these electrons there, we put a bracket around the whole thing, including the electrons, and the charge outside the bracket to say that this whole thing has a charge of -1. Okay, so now let's do some other examples. The first example we're going to do is potassium chloride. So potassium is a group 1 metal and will have 1 valence electron. Chlorine is a group 7 non-metal, so we'll have 7 valence electrons. So the first step is to draw in the atoms with their valence electrons. So potassium 1, chlorine 7. Now the next step is to draw those optional arrows to show the flow of electrons. So the potassium is a metal, the chlorine is a non-metal. The potassium will give the electron to the non-metal to form an ion. Once you've done this, then you just draw the resultant ions, including the brackets and charges. So potassium has lost 1 electron to obtain a +1 charge, and chlorine has gained 1 electron to have 8 valence electrons and a -1 charge. Now we just draw the bracket around the chlorine with the valence electrons inside and the charge outside. So our resultant thing looks like one potassium ion next to a chlorine ion. Because this is a one-to-one relationship, it doesn't really matter how you draw the potassium and chlorine in here. So the next example we're going to do is sodium oxide. So we write in the ionic formula for sodium oxide, Na O. Now remember, the oxygen has a -2 charge and the sodium only has a +1 charge. So you'll need 2 sodiums for every oxygen in the ionic formula. That's done. Now you just draw in your atoms with their valence electrons. Sodium is a group 1 metal, so it has 1 valence electron, and we have 2 of those. Oxygen is a group 6 non-metal, so it has 6 valence electrons. So now we just draw those optional arrows to show the movement of electrons from the metal to the non-metal. And then you draw the resultant ions, including brackets and valence electrons. Sodium has a +1 charge because it's lost 1 electron. Oxygen has a 2- charge because it has gained 2 electrons. It has the full outer shell, 8 electrons in the outer shell, and it has brackets around the oxygen and the electrons. The charge is on the outside of the brackets. So you can see that when I've drawn the final structure, I have a pattern which makes sense for the ionic compound, with the sodiums surrounding the oxide ion. A helpful hint is that the non-metal ion will always have 8 valence electrons once it becomes an ion, because it becomes an ion to gain that filled outer shell. Okay, so the last example we're going to do is aluminium oxide. Aluminium has a +3 charge. Oxygen has a -2 charge. So, to write the ionic formula, you need to balance these charges. What you're going to do is you increase all the charges to 6 by adding subscripts. So, aluminium is going to have 2 of those, and the oxide is going to have 3 of those. So this is our final ionic formula. Now we're going to draw the Lewis dot structures. You draw the atoms out first with their valence electrons. Okay, so our aluminium has three electrons. Our oxygens have 6 electrons. Now we draw the arrows to show the passing of electrons from the aluminium metal to the oxygen non-metal. So the aluminium gives 2 electrons to the first oxygen, and 1 electron the next one. So this oxygen now needs 1 more electron. It gets that from the other aluminium ion, and the remaining 2 electrons on the aluminium go to the oxygen, like this. It looks very messy. If you want to skip this step, that's fine. The final part is to draw the ions with their brackets and the valence electrons clearly inside the bracket, along with the charges. Aluminium has lost 3 electrons to get the 3+ charge. Oxygen has gained 2 electrons to get a 2- charge. We still have to draw in 1 more oxygen, and this needs to be on this side in order for the ionic crystal lattice structure to be represented in the final Lewis structure. Okay, so this would be your final structure, with the oxygens containing a 2- charge and the aluminiums containing a +3 charge, brackets around the nonmetals, and the valence electrons inside those brackets.